Hello, everyone. My name is Xiongfeng. I'm a master student from Rice University, and my major is computational science and engineering. This summer, I joined the SkyhookDM team and helped with the server-side development. So today, I'm going to present my works, SkyhookDM projection-only pushdown, and Arrow Dataset API integration into Skyhook objects. This project is mentored by Jeff, Ivo, and Noah. Okay, first, the Skyhook data management features programmable storage for databases. It utilizes and extends the object storage and classes in Ceph. It supports common data management operations like select, project, and aggregate. So these operations are directly pushed down into the storage level. And now the Skyhook supports flat buffer and arrowed as data type. Okay, in my project, there are three phases. The first one is the Skyhook projection only pushdown for arrow table. The second is in storage arrow list array data type operations. And the last one is set up arrow native Skyhook architecture. And I will introduce you one by one. The first one is projection only pushdown for arrow tables. So what does it mean? So for example, in this query, select A, B, where A is less than 2 and C is greater than 1. Here we will need 3 columns in the tables. Even though we only need the data from column A and B, we still need this column C for the predicate. So what we want to implement is to get these 3 columns and make a projection and return it to the client side. So we don't return all of the whole table, but only the columns what we want. And the second example is also similar. So you can see the workflow of my implementation. On the left side is the original one. So just input query like is projection is mu1 and the predicate is A equals to true and B equals to true. And I will modify the query schema from the mu1 to mu1 and A and B. And I will also set the query predicate to an empty set because the predicate will be executed in the client side after the projection. So this is why it's called projection only pushdown, because we only do the projection, the column projection in the server side. The second phase is list array and reducer operations. So because in the arrays heap, a common data format is jagged and jagged array, and they are stored in Skyhook as arrow list type. So the list type, it means that each entry in the column is a list of arbitrary values, and the length is non-uniform. So we would like to. So at first we would like to implement some some reduce operations like the min and max and count. And however, later we found the compute APIs in the Apache Arrow libraries. So we come to the compute APIs, and I dive deep to check the source code and document and make documentations for this. So here we will use API aggregate because of this aggregation function. So the third phase is moving to the Arrow API. So later we found compute API and also the dataset API. We found that especially for the dataset API, there's a filter and a projection method that will be great helpful for the Skyhook development. And here's, after some group discussion, we have this basic structure of the future design. And I was responsible for the test setup. for the storage side development. So basically, I have done two things in the third phase. The first one is setting up the running test for the arrow CIs. I linked the arrow and the arrow dataset API to our C++ code and wrote some unit test. The second one is to make use of the in-memory fragment in the dataset API. This in-memory fragment and the scanner class are very important because we can do the filter and the projection in the arrow table, and so these functions are native implemented in the arrow. So we don't need to write our own code anymore. So here's workflow of my implementation. At first, I create an arrow table with fake data, and I use the table batch reader and the schema to generate a in-memory fragment or data set. Then I create a scanner builder from this fragment and the schema. And in the scanner builder, we can do the filter and the projection directly here. So we don't need to write our own code. We can just call the API. So it will be much more convenient. And after that, we get the scanner, and we can read the filter data and convert it back to an arrow table. So that's all. So thank you for listening.